Şimdi zirvenin ilk bölümü, ilk gününün ikinci bölümüne başlayacağız. Konuşmalarda da oldukça geçti. Şimdiki konuşmamız da yine yapay zeka ile ilgili. Ben biraz merak edip Financial Times'ta yayınlanan Can We Just Have One Day When No One Mentions AI başlıklı bir makaleye göz attım. Burada küresel çapta haber başlıkları incelenmiş ve bir günde haberlerde kaç kez yapay zeka geçtiği incelenmiş. Tahmininiz var mı? Küresel çapta bir günde yapay zeka haberlerde kaç kez geçmiştir? Herhangi bir tahmin olan var mı? 1000 dediniz. 2100 kez geçmiş. Mesela diyelim ki bu sene 3 Ağustos'ta küresel çapta haberler incelenmiş ve başlıklarında yapay zeka 2100 kez geçmiş. Peki geçen sene aynı gün kaç kez geçmiş olabilir? 200. 764 kez geçmiş. Yani 3 katına çıkmış. Önceki yıllarda 15'e kadar düşüyor bu. Şimdi sırada Sigortacılıkta Dijital Dönüşüm ve Yapay Zekâ, Yenilik ve Etkinin Güçlü Yolculuğu başlıklı ana tema konuşmasını Willis Towers Watson Global'dan InsurTech İnovasyon Lideri Sayın Magdalena Ramada Sarasola yapacak. Kendisini kısaca tanıtmam gerekirse, Willis Towers Watson Global'da kıdemli direktör ve Global InsurTech İnovasyon Lideri olarak görev yapmakta. 20 yıl aşkın süredir Ar-Ge ve uluslararası strateji danışmanlığı deneyimiyle sigortada dijital dönüşüm, blok zincir ve veri analitiği konularına odaklanıyor. Risk transferinde yeni teknolojilerin uygulanmasında öncü olan Sarasola, aynı zamanda konuşmacı, eğitimci ve teknoloji yönetişimiyle kadınların teknoloji alanındaki temsilinin destekçilerinden. Şimdi Sayın Magdalena Ramada Sarasola'yı konuşmasını yapmak üzere alkışlarla sahneye davet ediyorum. Welcome on stage, Magdalena.
Good afternoon, everyone. Thank you for having me, first of all. And as you just heard, I've been doing technology, advanced technologies, new technologies in the context of insurance for 11 years. Today I'm going to be spending some time on AI and why I believe that, yes, there is a lot of hype, but there is a lot of substance behind this. And we have been investing some of our resources into actually going into experimentation and seeing where the boundaries are and what the art of the possible looks like. So, essentially, we have had a lot of hype about Gen AI and about agentic AI in the last 2 years. And it feels real, but there is still a lot of people that think that it's very difficult to understand if the impact will be like digitization 10 years ago or blockchain 15 years ago, or if really something significant will modify the insurance industry. And I'm going to try to convince you today that it is real. But before I go there, I want to define what AI is. Why am I going to start there? Because a lot of people are saying that they're doing AI. And when you look at what they are doing, I wouldn't consider it to be AI. A lot of times it's machine learning, sometimes it's just predictive analytics. And so what is AI, and why is it important that we define it? In other contexts, like the regulatory context, we have very clear definitions. But when it comes to activities, we have to define which tools we use. So when you start tracking a new technology, technologies evolve in the Gartner curve, and usually you have the technology as one thing evolving through the curve. When technology matures, you start having multiple flavors of that technology across the curve, which is what we are seeing with AI and with generative AI very specifically these days. So there is a lot of different things that we could call AI and that we could deploy in the context of insurance. What is the critical thing that makes AI AI and nothing else? We are, as humans, we process information in a certain way in our brains. So what makes AI AI is that it tries to imitate human intelligence in the way it happens and in the type of outcomes it has. So a lot of people confuse AI with the ability to predict. Predicting is part of AI has to do, because if you want to take decisions, you are predicting all the time. You're predicting the outcomes of your actions. It's something we do unconsciously all the time. So predicting is a great part of AI, but it's not what makes AI AI. What makes it AI is that it mimics the way we think, the way we process images, the way we understand language. So when we look at AI and the way in which we're deploying AI, a great part of what we're using AI today to do is predict outcomes, right? And those outcomes can be very simple outcomes, or they can be very complex. They can be independent, they can be interrelated. And when it comes to risk, we know what prediction is all about, because we have been predicting things for a very long time. It's part of our DNA as an industry to predict things. So AI becomes an additional tool to predict things, but its core, it's not predicting. Its core is that it tries to predict in the way we would and in the way our brain works. And so it becomes a tool for decision-making, which involves predicting, but is much more than that. So as an industry, we have been predicting for at least 40 years. I would actually say that from a standard perspective across the industry, for the last 25 years, at least from 2000, when it became standard practice across most insurers in the world, we have been doing predictive analytics and predicting things. Initially, we would use what I call traditional predicting methods, right? Statistical methods that have a statistical core set, they have rules, and you cannot get out of those rules. Your data has to behave in a certain way. If it doesn't behave in that way, you treat them as outliers, you try to reduce everything, you try to reduce the noise according to certain models. So you use like a structure, which is a statistical method structure, to do your prediction. While we evolved as an industry, some 10 years ago, we started doing machine learning. What was machine learning? It was essentially loosening up a little bit that statistical core set that we had on our models and our data, and leaving these models and these algorithms to learn from data structure and to interpret what content is in the data from the data itself. And so machine learning became something that for the last 10 years we've been adopting. I mean, most advanced insurance markets use machine learning in the context of pricing. And it is also nothing new to us. There is a part of AI that we have also been using for almost 10 years, which has to do with things like voice-to-text and transcriptions and image recognitions. And these are, areas of AI that are based on the idea that they are neural. What does neural mean as opposed to neuronal? It imitates our neuronal structure, which is a physical structure in our brains, in the way it actually generates insights. And so these deep learning methods are neural. And we have been using them in risk prevention. We have been using them in recovery after a disaster. We have been using them in autonomous driving for a very long time. And that's where you have convolutional neural networks and recurrent neural networks and a number of methodologies that shouldn't be strange to anyone doing pricing. And in the context of claims, they have been widely used as well. So that is AI, but that is not the AI we're talking about right now. So what is the new AI? The new AI is generative AI. So 2 years ago, we were faced with an invention. It's a bit older because the first paper around it is 2017, which was ChatGPT, and our ability to actually talk to an algorithm and extract information as if we were talking with a human. So what makes generative AI different from these other AI tools? It uses a lot of them, but it has the ability to synthesize information and to generate information. It's in the name. So that is the core differentiator of Gen AI with other types of AI. It is that it generates content. And then, I think like a year ago, everyone in the industry and most conferences I go to started talking about agents and agentic AI, and how agents were going to do pricing and underwriting and claims, and we would have artificial agents dealing with most of our processes and activities. What is in the difference of agentic AI compared to other things we had? Well, the word is also in the name. It's this agency. And what do we mean by agency? We mean the ability to have purpose and initiative. So there is an autonomous element in agents that we didn't have before. They can make autonomous decisions. So when we talk about the hype, right, we need to understand, when you look at new technologies, which has been my job for a very long time, you have to understand what is this technology doing that we could not do before, because that is what is going to determine if it's going to have a significant impact, a moderate impact, if it's going to be something incremental, it's going to be revolutionary. And so generative AI and agentic AI have a number of traits that are significantly different from what we could do before with predictive modeling, with machine learning, and even with other techniques that are based on deep learning. So what makes generative AI different? There's three pillars there. The first one has to do with scale and complexity. The architecture of generative AI, what is behind the way in which the algorithm thinks, is very complex, and I'm going to try to explain it in very simple terms in a minute. And it is based on deep learning, like other techniques we had, but it has a new type of deep neural network, which is called a transformer. And we didn't have that before. The first time we thought about that was in 2017. So that is fundamentally new. The other thing it has is it requires a lot of data to be trained. So there has been a concentration of ownership of these algorithms because it's very expensive to train it, and you need a lot of data to be able to train a large language model. But it has some capabilities that we didn't have before in any of the other types of AI I mentioned and predictive modeling and machine learning techniques. And those things are things like few-shot and no-shot learning. What does that mean? That I can give it a task without an example, and it will figure it out and solve the task. I can give it a task with only one example, and it will be able to do it. It can also generate transfer learning. I'll give it a task in one area of knowledge, and learning from that enables these models to actually extrapolate it to a complete different use case and area of knowledge. We didn't have algorithms that were capable of doing that before. So that is fundamentally different. The other thing that these algorithms have, or these techniques, is emergent abilities. So emergent abilities means they develop skills on their own without you asking and without you teaching those skills. So this type of system, this type of technology is really different from what we used to have. If you look at agents, right, you're actually embedding something that has a brain. But so an agent essentially is a system that has a brain that can perform actions, and it is autonomous. And now in that brain, we had agents before. A lot of automation is based on agents. But now the brain is not rule-based, but it has an LLM inside, and it has generative AI inside, generating decision-making. So that is fundamentally new. But like every agent out there, you need to, they cannot work in a vacuum. So I like to have the analogy of agents being like interns. We all have interns in our organizations. Would you let an intern do your reserving? No. Would you let an intern do your pricing on their first day? No. But you would have them have a first shot at things, right? And that's the way in which we're interacting with agents. When you have an agent, you talk to it in the same way you would talk to an intern. And some agents have different personalities, they have different skills, and like interns, they get tired, they get bored, they stop listening. So they behave very much like, my kids. I have 2 teenagers, and a lot of the time you give them instructions, and they just ignore half of the instruction. That also happens to AI, and it happens to agents. So one of the first pillars of interacting with an agent is to learn how to communicate with them, which is what is all about, prompt engineering and all of the hype words we have seen around prompting right now with generative AI. So you communicate with them, and you have to learn that different agents need different techniques of communication. But then you've learned what an intern can do, you're good on the communication, and you'll have to give it some tools and some processes and say, no, this is how we do things in our company. This is the software you're going to use for pricing. This is the software you're going to use for data validation. So you have to provide a context. And in the same way you would provide a context for an intern, you have to provide a context for an agent so that they understand the processes and the tools they're allowed to interact with and have an impact on. And once you have done that with an agent that is able to do one certain type of tasks, because many of these agents specialize, you have to orchestrate multiple agents. And this is a critical part on interacting with agentic AI. Orchestration is what gives you robustness, what minimizes hallucinations, what minimizes bad outcomes. So the way in which you actually interact with these agents is critical to how they perform. In the same way, if you have an army of 1,000 interns, you have to think very clearly about which teams you put together and how they work together. Okay, so let's take a little bit deeper dive into generative AI. And there's going to be formulas out there, and I'm sure there's a lot of actuaries in the room that are not going to be very intimidated by a weighted average, but I'm not going to be very technical about it. What I want you to leave with today is the intuition of what makes generative AI and transformers different, and why they can deliver things we could not deliver before, but also why, because of their own architecture, there's certain things that we will have to deal with because they will not stop hallucinating. You cannot lower their temperature, which is like the freedom they have to go off track, to 0. So there's certain things in the architecture that make it very powerful, but that also generate things that we never had before, which is the unpredictability of the algorithms we're deploying. Okay, so what are transformers? Transformers have an architecture that essentially has an encoder and a decoder. And the way they do understand the world is paying attention to certain things with what we call attention functions and self-attention functions. We all have attention functions in our brains. So every day, we take a lot of decisions. And the way we do that is with weighted averages, right? If I want to eat chicken, I will change the weights on what I look at a menu. And certain things will be interesting and others will not be interesting because I decided that I wanted chicken. So a lot of our decision-making is based on paying attention to the things we decided we want to pay attention to and not paying attention or neglecting the other things. So transformers do the same thing. The other thing they do is, instead of being recurring, instead of being sequential, which is what we had with previous AI methods like CNN and RNN, they can do parallel processing. So instead of having one attention function like we have in our brains, or if you're a good multitasker, perhaps you have 5 attention functions, they have hundreds or thousands of attention functions at the same time, operating in a parallel fashion and processing information in a parallel fashion, which makes them very quick. And because the way they look at things is not sequential, they need to understand positions. And the way they do that is by developing like a secret language. So essentially, you will have attention mechanisms that are functions where Q is a query, is the question you ask it. Key is a key, things like what matters in this context, I want to eat chicken, I don't want to eat rice today. And then there is V, which essentially gives you the values that determine those weights in that weighted average function. But instead of having one, you have multiple ones, right? And I don't know if many of you have learned how to do quick reading, but there is a quick reading technique that is very similar to the way these algorithms capture reality. So when you do quick reading, at the beginning, you will have like a little window, and that window is going to show you a word for a second. And then you retain the word and say, OK, word A. And then that window starts expanding. And you train your brain to be able to understand 3 words, 5 words, 10 words, a whole paragraph with 1 second and 1 glance. The only way you can do that in your brain is if you're not processing it sequentially. And that makes a quick reader, and makes a huge difference. If you're not reading sequentially, but you're apprehending the information as if it was one symbol, like in the Chinese language. So this is one of the things transformers can do. But then they have to figure out how to connect all of those things. So essentially, that's why you have a function that's about the positioning of those things. So what do? They look at words, and they look at sentences, and they look at meaning, and they generate like a secret language of understanding all of that by putting that into a multidimensional matrix. So the way it works is, say we have fruits, right? One way of understanding fruits and finding similar fruits would be, I take a fruit and I decide that fruit has 5 dimensions or 4 dimensions. It has flavor, it has color, it has size, it has sweetness, right? And I define those dimensions in a vector, and I describe bananas and apples and oranges in that way. And then if I want to find something that is similar to an orange, I will look for a vector that has a similar dimension and that is close in a multi-dimensional space, close to the vector of the orange. The thing is that when we do that process, and it's how we learn languages, we transform, we have senses for all of those dimensions. And those dimensions are size and color and sweetness and sour or pain, level of pain. We have dimensions that we understand. When these type of models, transformers, large language models do this, they develop their own way of doing it. And so essentially, you don't know what those numbers and those vectors mean. And instead of being 5 dimensions, they can be 500 dimensions. And all you control is how many dimensions you want that model to decompose meaning and words into. So that's why I talk about a secret language. And every large language model, even every new version of GPT that comes out, has a different way of encoding and generating those matrices. And there is no human possible way to understand the way it decodes and generates those vectors. So vector databases become a given, right? And they become a given, and they are based on the training that most of these models have received. And these models have, been trained on data in the internet. So if you want your kids to learn about the world, how many of you think training them on what's out in the internet is a good idea? I don't see many hands. Because, when you train on something as vast as the internet and something as biased as the internet, the results you get are not really specialized. They don't always make sense in different contexts. So one of the things that science is really trying to figure out right now is we have large language models. They operate in this way. We have a handful, or a bit more of a handful, of providers of these large language models. They have been trained on data sets and information that we do not control. They're based on a secret language developed by the algorithm that we cannot understand. And we need to understand if we can use them, for instance, for insurance, in a specific context and for a specific purpose. And so a lot of science, what the science is doing right now, and for instance my team is doing, is working on what we call augmentation of LLMs, making sure that we can use them for very specific purposes so that they improve the way they act. This is not only important because I told you, right, they can learn on their own. So perhaps we can take a general ChatGPT and at some point it will be able to do reserving. But the time it will consume and energy and cost to get there is very high. So some people started working on different techniques of taking these models and making them more fit for purpose. Prompt engineering is one of the ways we interact with these models that changes performance. But then there's things like fine-tuning, where you reparameterize some of these models and change their secret language so it's more geared toward your use case. There is RAG, which essentially is telling this large language model that there is a number of very specific things that it needs to encode with the same secret language and enrich its decision-making by using that depository of information. So say you want to have an LLM or an agent that generates documentation for you about how you did certain modeling. Well, you have reports that you have been generating for years. So you put them into a RAG repository, you generate a vector database in the same secret language of the agent, and then the agent understands that that information needs to be part of its decision-making, and not only what it learned out there in the internet. There is a number of things that you can do with these large language models, and this is where science is looking at the art of the possible right now. What tools can we use to have, a more stable outcome of generative AI and agentic AI? What are agents? Agents are essentially a construct that has generative AI in them, right? And so essentially every agent has that structure. They live in a certain environment, and they have a goal function. That goal function can be deterministic, it can be stochastic, it can be very complex, it can be very vague, it can be very specific. So they have simply a subjective, an objective goal function, right? Where they have to determine if they fulfill that goal. And that goal could be find ways of dealing with climate change, and if that's as vague as that, you can have very bad outcomes. So my son is now 16, and when he was 11, he told me, "Mom, if you tell an AI that it has to solve climate change, it will just kill us because we are the problem," right? So you have to be very specific about what that objective function looks like. Then some agents have memory, others do not have memory. Some learn from your interactions and reparameterize, and others don't. But they all have this brain or perception where usually you will have generative AI in there. And the way they act is they define actions, they execute those actions with the tools and context you have given them, and then they will perceive what happens in the environment because of what they did. So essentially, all of the agents have this structure, but depending on what type of goal function, what type of memory, what type of brain, what type of tools you give them, they perform very differently. A good example of how this works in the real world is what we call the React agent. The React agent is an agent that has an LLM as part of its brain, but it is able to verbalize its chain of thought. So I don't know if you have been using the researcher agent at Copilot or DeepSeek, for instance, where you can see the AI thinking through the process. I'm now going to look at that. I'm deciding if I click in this. And essentially, sometimes it looks like Catcher in the Rye. You have an AI there thinking, I need a virtual coffee, right? And it takes a lot of time going down rabbit holes that you shouldn't go down to if it knew what it was doing. So the ability to have that chain of thought enables us to interact with the agent and say, stop, no, you don't want to go there, that's unnecessary, or you didn't understand. This agent is able to self-reflect on its chain of thought. So that's why it's called a React agent, because it learns from its own thinking. And it has the ability to dynamically change and adapt based on what it learns about its own thinking. So there's a lot of very different types of agents out there, right? And some of these agents don't even look like AI. If you look at the first one up there, the simple reflex agent, a thermostat is that type of agent. It has a role, it reacts to a trigger, and then it executes something. Turn on the heating, turn off the heating, right? That is an agent. Is it a very smart agent? Define smartness. It is rule-based, and it only has two types of outcome. When we go into more complex type of agents, we will get to agents that have the ability to optimize, that have the ability to fulfill a goal in a more self-conscious way. And so there's a lot of ways in which we will be able to build these agents, depending on what we put in the brain, what we put in the memory, how we define the goal function, what tools we give them access to, and how much autonomy we give them. In the context of insurance, there's a number of things we can do with agents, and many of you might have already started doing these things, right? So we like to talk about two ways of using agents. The first one is what we call isolated Gen AI cases. And this is your Copilot from Microsoft. It is read my email, summarize the last 3 meetings I had, take meeting notes. It's really more about efficiency gains, and it is day-to-day tasks that are not very technical and that actually apply to most industries. So this is really about accessing data, and using the ability to synthesize that many of these agents have. When it really comes to now let's use this to do things we could not do before, like intelligent automation, like autonomous agents doing things in our technical functions, that's when you go into the agentic AI space and the uses that you could give AI in the context of agents. And it's really more about the processes because of that orchestration need that you will have with agents. So essentially, when we look at different ways of interacting with AI, you will have certain areas where you will not need to embed expertise. You will not need to embed what you know as an underwriter. You will not need to be specific and use specialization. And those are the ones you will have on the right. They're really about increasing productivity and doing things that we can do with other types of methods, but this is sometimes quicker and cheaper. On the other hand, you have areas where there is more complexity and where we really need to have a human in the loop that is governing that orchestration of AI that you can use to do some of these things. So governance becomes very, very important, and oversight becomes very important when you're looking at that left-hand side. When we have certain agents and they are working, and so now I have an agent that is able to generate documentation for my regulator, and now I have another agent that is able to clean my reserving data, and now I have another agent that specializes in generating insights of certain changes based on macroeconomic trends. And so I have different types of agents with different levels of complexity, and I have to orchestrate them. So how do I orchestrate agentic systems? There's lots of ways of doing that. You could actually say, well, in the same way we used to orchestrate teams in the past. You can have a hierarchy, and then you will have someone in charge, and that is the agent in charge, and you have other agents reporting into that agent. Lemonade, for instance, the new insurer from the US, they have been doing this for a long time. They built an infrastructure called Cortex before agents were fashionable and hyped. And they have different agents dealing with customers, with claims, and they don't use agents in the context of technical functions, but they do have agents with a lot of autonomy for certain of their use cases. And what they have is a supervising agent that orchestrates these other agents, and they all have human names. Then you could have behavioral-based orchestration, which is you give all of the agents one task. So this is how drone swarms work. I don't know if you know, but there is like little drones that behave like bees, and there's bee drones that are trying to help us with the fact that bees are getting extinct and we really need them. And the way they are controlled is you have a function for all of them as a swarm. And so they interact with each other in the same way bees do, and there is like swarm economics going on, and they all behave like one team towards one goal, but you don't define what each one of the players in that team is doing. So that's what we call behavioral-based orchestration. And then there's different ways of orchestrating these agents. They could be market-based, and then you just define, a frontier, an efficiency frontier, and you let them behave like in a market, maximizing a certain function subject to some restrictions. The tricky part is when you have all of these agents, you have to find the best way to orchestrate them to get the result you want. And that is where most of the research is going into today, because it's not as easy as it seems. Okay, so what does this mean for us as an insurance industry? And how much of this is really happening today in insurance? As I said, the tech is real. It is different, and it's real. It's here. It's deployable. It's scalable. It has been in our lives for at least 2 years now. The hype is real. You can see it there. That essentially those curves are looking at LLMs and ChatGPT in the context of insurance, and the increase is palpable in the news and in Google search. So how much is this actually going into our companies? Well, we have a survey every year, and that survey looks at what companies are doing and where they are going and where they want to invest. And we have 89% of respondents saying they're planning to invest in generative AI and agentic AI and deployment. But there's half of them that say that they already adopted it. There's different levels of adoption, right? Some are just, OK, we use Azure, then we have Copilot, and essentially there's some levels of adoption that are more to those generalist cases of isolated cases. But there is also insurers in Europe right now that have sizable teams, 5 to 15, 30 people, looking at agentic AI in the context of claims, in the context of underwriting, in the context of words and policy wording. So it is real. We are really seeing some of these companies investing into seeing what the art of the possible is and how many of those techniques of LLM augmentation work and which use cases need what type of augmentation. So, as I said, we have different techniques to do the things we have to do, including prediction. And they are sometimes adequate and sometimes overkill for certain of the things we have to do. So essentially, throughout these techniques, ranging from predictive modeling to agentic AI, you will have different attributes, different cost, different inputs needed. And that will make them more suitable or less suitable for what you're trying to do. So differentiated applicability of all of these tools and understanding the difference between these tools is key to be able to have sustainable systems in terms of performance, but also in terms of cost. So this slide essentially is looking at how are we using this in the context of the insurance industry, and what are we seeing in the market? And the answer is, you don't want to be using generative AI for everything, because certain things can be rule-based, and certain things can be modeled with traditional techniques and don't need a generative AI to think about it. And it's a lot cheaper and sustainable, and it works better if you do it that way. So if you look at the value chain down there, right, and all of the technical functions in different areas of the insurance value chain, you will see the dots. And the dots get smaller the less suitable a technique is in a certain type of use case. And the darkness of the dot gives you the adoption. So if you look at things like claims, the transition has been from dark to less dark, right? Which makes sense. We are using the older techniques in claims more. But you still have a very sizable size of agentic AI in the context of claims. It is the one area of the value chain where we really are seeing many insurers invest and get interesting results. If you look at areas like pricing and underwriting, there has been more experimentation, and so those dots are there, but they're smaller, because it's a bit trickier to have agents and LLMs dealing with your pricing and your underwriting. And depending on how you define those functions, those dots can get a bit larger. So for instance, in underwriting, generating underwriting rules and understanding how to underwrite is something that you could try to do with an agent, but the volatility of the results would be too high. On the other hand, if you have more structured data, your agent does a far better job when looking at structured data to make decisions. So instead of using the agent to just make underwriting decisions and become an underwriting agent, what you do is you use it to structure data for your unstructured data sets. So there is applications within underwriting that are not specifically about the underwriting itself, but that make underwriting something a lot more data-driven. So essentially, what I'm trying to tell you today is AI has been here for a while. The hype we're feeling, and we have seen in the last years, is significant. But the way in which we deploy these tools actually has a large impact on what we can do with them. So it's not like before we would say, OK, we used to have DLMs, now we have GBMs. They increase predictability, they're a black box, but for certain contexts I can use it, and GBMs usually behave in the same way when you deploy them. This is not the case now. It's not like one tool that you will deploy always in the same way, in the same place. There is a lot of playing around and experimentation until these things work. And what it really will modify in the next 5 years is how we think about processes, how we think about automation, how our target operating models work, how we connect technical functions and allow technical functions to converge, how pricing and underwriting and claims data will influence reserving in a more granular and timely fashion and will have a direct impact on capital modeling, and how technical functions and insurers will converge in the way they look at modeling and data, because we have tools that enable us to do that in a more effective and quick way. It will also change the way you design your systems. And so software is being architected in a different way. And these agents need to be able to interact with tools. So for instance, we produce a lot of tools and technology. And we had to re-architect some of that so that an agent can go in and do pricing, and do a segmented trawler, and refit a model, and have the autonomy to interact with that software that was designed initially to interact with humans. And now it has to interact via APIs and via MCPs with some of these agents. So the way we develop technology and the platforms we develop is also changing. And obviously, it has a huge impact on data infrastructure and availability. The way we are able to structure data, extract data, and liberate data today we didn't have in the past. It's one of really the superpowers of these models. They are conversational. They are trained to understand language, and therefore they can extract from unstructured data, from text, a lot of information and insights that would have been extremely costly to do in another way. So a couple of years ago, in the context of commercial insurance, we were working with what we called computable contracts. What was the idea of computable contracts? Essentially, it was to have contracts that are code and code that are contracts, so that contracts are machine readable, and we can extract information from contracts at clause and subclause level. To actually transform one set for one line of business and one type of parallel of contracts into a taxonomy that could enable to generate that code took 6 months of a lot of very bright people 5 years ago. Today, you can actually use LLMs to do that in a very efficient way. So generating structured data out of unstructured data is one of the big superpowers and low-hanging fruit that we have. And then the other thing that will change is how we work. Because we will not only have to orchestrate agents, we will have to orchestrate people and agents together and understand where the governance checkpoints need to be and at what level, but also understand how we can use some of these things to train people and to make sure that people still get trained on the job, although there is an AI doing a lot of the things and getting their hands dirty that usually were, the processes through which we used to train people when they started working. So it has people implications that we also need to think about. So essentially, we have moved from automation, which was a big word 10 to 15 years ago, to augmentation, which has been the driving force of the last 10 years with machine learning, which was all about augmenting decision-making, generating insights in a timely fashion, having decision-making engines that allow you to have data-driven decision processes in your organizations, to now move from augmentation to autonomy and to autonomous systems. And the key things in that autonomy will be determined by how you orchestrate these tools and how you govern them. So what can go wrong? Lots of things can go wrong. I have a 1-hour meeting every Monday with my pathfinding team, which essentially are people that are paid to have fun experimenting with these things and figuring out what they can do and what they cannot do. It's the best hour of my week. And it's mind-blowing what they get done in a week and what is happening in the world around us week after week. But it's also true that you might have fine-tuned a system and have something that is generating reports or is enabling you to do cleaning of your reserving data or is doing, automating part of the insights that you need in the context of underwriting. And so you have orchestrated it. You're working with an agent, you worked on the prompts, you augmented it with the right information, the documents are being generated, and then we go from 4.0 to 4.1, and the model starts behaving in a complete different way, and it doesn't give you what you want. And that is a problem we have, because these large language models and Gen AI are based on transformer architecture and are based on updates that we do not control. And that sadly, not even OpenAI or DeepSeek or Microsoft really know how they can, when they do these updates, it's very difficult to predict what will change in the model's performance. And so if you're basing a whole automation on that, that can really backfire. So essentially, there is a lot of things that can go wrong. There's things that can go wrong in terms of governance, in terms of stability, in terms of not being able to control the outcome of the things you're building in your organization. In the sense of some of these tools are generalist tools, and they will not perform in the specialized sense in which you need them to. And then there is societal risks. Right? Because we also have to decide what we're going to do with all of that increased productivity and what this means for people's identity and what they are going to do with their free time and what this means for concentration of data and capital. So the societal implications that we also need to be aware of, and that really, there's a lot of risks that we need to understand to ensure them and to avoid them. But I like to say that I believe a lot more in utopias than in dystopian futures. The upside of actually using these tools in the right way is incredible. It should enable us to close the protection gap. It should enable us to understand risks with new data sources, with non-historical data, to develop appetite and understanding for risk assessment and risk pricing in new areas. It really should allow us to lower the cost of bridging risk to capital. There is so many things that we could do with these technologies that directly speak to our mission as an industry, that I really believe that there is no way around of embracing it. We have to be very cautious on how we embrace it. It's not as simple as many people on stage used to say, but it is imperative that we start now. I really think we have a responsibility to society as an industry to use these tools to be able to assess risk in a different way, because the level of granularity and specificity that we will get with these tools, we couldn't have not even 5 years ago. So I guess my last famous words is, you have to start somewhere. So if you want to start small, you start small, but you have to start now. There is a true sense of urgency in actually starting to deploy these things and making people comfortable with them. I remember 6 years ago, I was on stage here, and we had someone from a European insurer on stage, and he said, yes, we have these algorithms, and now certain claims can be processed in less than 2 minutes. And then we had people in Switzerland saying, oh no, they didn't take it seriously because this is too quick, so they didn't look at my claim properly. And what this company did back then, and it's a true story, was they put a buffer of 5 minutes into the decision-making process. So the decision had been made in less than a minute, but then people would get the result in 10, because that's what they expected it to be. So the cultural aspects of embracing this are very important, and that the journey should begin now, with you knowing more about these things and really having your teams look at them. I will finish with one sentence that So Anthropic is one of the big players in this space, and his CEO told our CEO that AI is one of those things where you're either at the table or you're on the menu. So you don't want to be on the menu, you want to be at the table, and that means really embracing this, which is much more than hype. It's very real. So I thank you for your attention, and I'll be here until tonight, so if you have any questions, I'll be around. Thank you so much.
Thank you, dear Sarasola.
My pleasure.
It's very brilliant, one of the brilliant presentation of I have ever had. Thank you very much. And I want to keep you on stage for just 1 minute for plaque. Ve plaket için Türkiye Sigorta Birliği Genel Sekreter Yardımcısı Sayın Aysun Yıldız Özer'i sahneye davet ediyorum. Biraz daha ileri gidebilirsek şöyle. Evet, ortaya.